Today I'd like to look at how we can differentiate exponential functions like this, where we have a constant raised to the power x. And there's a formula that you might have learned, but I'd like to go over a proof of why that works and where it might come from. So we're going to be using the definition of a derivative here. So like usual, we're going to take what we're trying to differentiate, c to the power of x, and that function is going to be our f of x in this limit expression. So we'll be taking the limit as h approaches 0 of the function but with a nudged input h. So next to the input there's going to be a little nudge h, c to the x plus h. And we're just subtracting off the regular function what we're trying to differentiate, c to the x, and that'll all be over h, just like this. From here it'll be a bunch of simplification, and we should get to the formula that you might have learned before. So we're going to start with breaking this apart. Using our exponent rules, we know if two exponents are being added with the same base, we can break them apart, and it'll look something like this: c to the x times c to the h minus c to the x over h. And from here we have two terms in the numerator, this guy right here and this one. They both have a c to the x, c to the power of x. So let's factor that out of both of them. So the limit as h approaches 0 of c to the x. When we pull c to the x out of this term, we're just left with this c to the h. And if we factor it out of here, well, it'll still be minus and just 1 over h. One more thing we can do with this c to the x is it doesn't have an h in it. So we're going to just take the limit of the rest of the expression here, and we'll pull this out in front. So we have c to the x times the limit as h approaches 0 of c to the h minus 1 over h. All right. Here's a bit of a creative part. It would have been hard for me to ever think of this on my own, but the next step will be to multiply the numerator and the denominator by the natural log, so I'll put this in brackets, the natural log of c, ln c, just like that. And we're going to keep it as we have it here in the denominator, where it'll just be h times ln c. But for the numerator, again, it doesn't have an h in it. We're going to pull that right out front. So it'll look something like this. We have c to the x ln c times the limit as h approaches 0 of just the numerator. We already pulled that out front. C to the h minus 1. But now over h times ln c. h ln c. There we go. We're going to do a little bit of work on this term right here, c to the h. So this will be a little aside. We can write something in this form, c to the h, as e to the ln c to the h. C to the h is the same as e to the ln c to the h, and that lets us drop this h out front. So what we're going to replace c to the h with is e to the h ln c. So let's do that now. C to the x ln c, the same limit, so h approaches 0, of e to the ln e to the h ln c minus 1 over h ln c. Okay, we're almost done. We'll need to do one more substitution, and we're going to choose a new variable and set it to equal this here, and it's also the same in the denominator. So let's call the new variable t, and t will be equal to h times ln c. And our goal now will be to get rid of all these h's and c's and to get them in terms of t. So we can do that easily with these, just replace them with t's. But we also know that t, it's defined in terms of h as well, and h is approaching 0. So we're going to need to swap our limits. How do we do that? Well, we're going to figure out what t approaches as h approaches 0. And as h approaches 0, we could just plug in 0. It's not in the denominator or anything. If we plug in 0, 0 times the natural log of c will just be 0. So t will approach 0 as h approaches 0. All right. C to the x ln c the limit as t approaches 0 of e to the t minus 1 over t. All right. This might look familiar or might not. This is a fundamental exponential limit. And I do have a separate video on this limit right here. But it evaluates to 1. So take a look at that video if you're curious for a more rigorous proof. Putting it all together, c to the x times ln c times 1, well, that'll just be c to the x times the natural log of c. Hopefully you found that useful and have a great day.